This is the Aftermarket Radio Network.
Hi everyone, it's Tracy Capriotto and Bill Weaver. It's October, so as you can see, I'm getting ready for Halloween. I'm waiting for Jamie Lee Curtis to come out wherever.
Nice Jason costume. Hey everybody, we're down at the EV Training Center, as Tracy said, and today we're going to take Tracy's mechanical ability and we're going to improve upon her skills because we're going to remove the top off of a high voltage battery pack that I removed out of this Chevrolet Bolt earlier this morning.
More than 16% of light-duty vehicles on the road are EV and hybrid. Is your shop ready to safely and properly service them? Get your shop trained and equipped to service hybrid and EV vehicles with NAPA Autotech's innovative EV-ready Level 1 high-voltage awareness and maintenance training.
Tracy's been through a lot of our training. She's been through EV Ready. They've actually been a participant in some of our classes and some previous training, so we figured it'd be a good time to get you out and expand your skills, and we'll take a look at the inside of today's modern EV battery packs. There's a lot of surprises, a lot of technology here, so we'll talk about some of the things that we have to do to stay safe. So the jokes about the Halloween costumes, guys, safety is not a joke. We are dressed in these garments because we want to make sure that we are protected and safe anytime that we are removing any kind of these high voltage components, especially when we get inside of the battery pack. The garments that we have on, whether we talk about Tracy's full length suit or my jacket and pants, both of these items that I'm wearing and the items that Tracy is wearing have an arc through protection value. Mine's 12 calories, hers is 13.2 calories per cubic centimeter. This refers to the ability of that garment to protect you in case we have what they call an arc flash, a lightning bolt, a catastrophic failure of one of the conduits inside of here that could seriously damage us. Now, while most manufacturers out in America right now do not force technicians to put this type of equipment on, other parts of the world that have higher standards for safety than we do not only recommend, but they require that we put arc flash protection of at least a level number 2, and we can talk about that in some future classes, but we need to make sure that we're protected the whole time that we work on an exposed battery pack. A lot of this has to do with the National Fire Protection Code. Some of it has to do with National Electric Code. Some of it has to do with OSHA. The bottom line is we're going to take the time to put on all this PPE because we put it on for our worst day. We don't don these awesome outfits that we have because we're going to have a good day. Just in case something goes horribly wrong, we're going to make sure that we are protected from head to toe. Not only will we have the arc flash protection on while we're doing it, we're going to don our cotton gloves, then of course our lineman gloves with the leather over it, and then Tracy and I are going to remove the entire cover off of the top of this battery. Once we get to the point where we're removing the cover on, we're going to don a hood, a balaclava, and an arc flash helmet because the most danger that we're going to run into is going to be when we remove this cover. Carm asked me a little bit earlier if this was out there because of just a mistake or whatnot. This is a simple Swiffer that you might find around your house. And if you look at the top of this battery pack, as soon as I removed it, I actually got a vacuum cleaner out and I vacuumed all the dust and dirt off of it. Then I went around and actually cleaned it. And I know it's hard to believe that a mechanic went out and cleaned something this meticulously. But what we do not want to happen, I do not want dust, debris, dirt, road salt, or anything that was all over the outside of that to get introduced into that battery pack. When we get inside of there, you'll see how clean and pristine that it actually is in there the whole time. So what we're going to do next is we're going to don our gloves because we're going to work around the battery pack. And anytime we're around this battery pack, we want to make sure that we put on our gloves and we're safe at any time that we would touch anything that could be exposed. Now, this battery pack, when I pulled it out, we used the scan tool that we have to shut the vehicle down. The vehicle's computer system allowed us to safely remove the outgoing power from this battery pack. But it's important to understand that no matter what we do from the outgoing power, the inside of this battery will always be live and it will always have energy in it. So how you doing? It's a whole lot, right?
The helmet is throwing me.
Yeah, it turns out your dad's kind of fond of you, so I guess we got to keep you safe.
Were these my gloves from?
Those are Tracy's gloves that come with the clown nose.
So in December, we're going to have to test them, right?
I've tested those this morning. I actually blew them up to make sure they weren't bad, but in December, we will have to send them out for recertification. So, feeling comfortable?
Oh, yeah.
It's a whole lot, isn't it? So what we're going to do is we're going to get our impact out. And a lot of people ask me, why would you use an impact on an electric battery pack? Well, actually, we have an insulator here that insulates us for over 1,000 volts. This particular insulator does not allow that piece of metal to touch that piece of metal. Therefore, this socket can never carry current through itself to the impact. Plus the fact that we have on our safety gear with our gloves, we're going to have Tracy take the impact and slowly remove the bolts. I'm going to follow her and collect the bolts as we take the entire cover off over here. So let's get ready and we'll get into the action over here. We'll start pulling this battery pack apart. I don't believe they started doing that again, literally after I asked them.
So who decides this is the order?
The manufacturer, if we look up the manufacturer's information, they gave us a specific order on every operation we have to do on this. What connector we take apart first, what's second, what's third, what bolt comes out first. So I've taken the time of numbering it the whole way around the battery pack to make it easier for us. No, this is stuff that we did after we've done this job a couple times.
No, where number one is that?
Well, look, I'll show you on the service information. There's a big map that shows up that'll tell us exactly what to do. So in orange, we have the removal. We'll start up at the top to remove these to relieve the penthouse. And then we'll start here at number 1, and we'll go the whole way around it clockwise until we end up over here at number 50. Now, when we tighten them back down, you'll see the order skips around because that's when we torque the cap back down onto the battery pack. We want to make sure it goes down flat.
So the green is for when you're putting it in.
Correct. Now, remember, we did this. The factory does not do this. We did this to make it easier and for what we're doing now.
Why didn't they do it? Does it help?
You know, that's a very good question. If we ever get to that level of people at GM, we should ask them that.
Wouldn't that be nice for people?
It sure would be for everybody, wouldn't it? So let's go to 1 and do the same thing we did around here and get these bolts away from our battery pack. That's the green is to tighten. Then we only did 1 to 50 because we're just going to go around and loose them in this order. So 1 to 50 around. Yeah. When we tighten, it's 1, 2, 3, 4, 5, 6. Tighten is in green.
Every bolt is the same, so it doesn't matter.
Well, these bolts, actually, that was a very good question. I was waiting for somebody to bring it up. These bolts are a little bit shorter, and I have set them aside. Very good that you thought about that. That's something we need to think about. I've had it apart many times, so I know. But in the class, I will let people get to that point, and I'll ask, how many guys noticed there was long bolts and short bolts? And then everybody stops talking for a second. I go, we have to pay attention to these things and set the bolts in the groups that they're at. So that is 56 bolts so far that we've taken out of this battery pack. 50 of them being one length, 6 of them being a little bit short. We talked about that earlier. The manual service disconnect is where that tape part is. That would be the part that separates the battery pack. On this car, it actually splits it in half. So we have one side of the battery pack, then the other side of the battery pack. That split it in half. We started with 376, 378 volts. And we're down to about 188 on this side and 188 on this side. So we're going to take a couple minutes. We're going to get our helmets off, get some fresh air. Then we'll come back in and we'll actually remove this cover, tip it backwards, and we'll see the inside of the battery pack. That gasket, we got to take our knives and we're going to make sure we're going to take these little plastic knives. Let me get around here. And we're just going to take our gloved hand. And as we pull up on it, we're going to hold the gasket down as we go around. If the gasket comes up with the lid, and I'll show you, these little metal things jump out and they jump into the battery. And that battery's 400 volts. And now we just threw metal washers into it. The whole reason that we're wearing arc flash protection is because I pulled this thing apart the first time. And one of those metal washers actually ended up inside of the battery. And it was very frightening while we're all standing around with the battery lid halfway off. We picked the gasket up, grabbed it the wrong way because the manufacturer really doesn't tell you exactly how to do this. They just say to remove the cover. So we found a better way, and that's what we teach in level 2, is if we're going to do this, here's a secondary method or an alternate step that you should be taking to make sure that you don't have the gasket stick to the lid and then these metal washers fly into the battery. I think it is a bad gasket design for not capturing them, but I'm not an engineer. I just fix the things and we're all done with it. So once we get it all loose, we'll take our fingers, and it's already broken loose, so it'll be kind of easy. Okay. We'll take the metal part under here. Once we get it up, we can hold this, and then we'll just take this tongue back. We'll eventually lift this thing straight up, walk it backwards, and then we'll tip it over so the inside is facing up, and this part is on the ground, like right there. Okay. So we're just going to pick it up, walk back a little bit, and we'll tip it right down, and all that part will be exposed. Tracy and I are ready. Tracy, what we're going to do is we're going to pull the top off of this, and we're going to give the world a reveal to what's actually inside of a high voltage battery pack. So one thing we're going to do is we're going to take our plastic non-conductive tool. We're going to start to separate the battery pack towards the front. Again, we want to make sure that that gasket stays towards the bottom. Now that we've got it broken loose towards the front, I want you to take your hand. Don't go too far in because we got a battery inside of there. Just on the flange, and we'll work our ways back, separating the top of the battery from the gasket to make sure that it's able to lift off, and the gasket stays with the bottom.
Okay.
So there's some plastic locating pins that tend to make it stick a little bit. So we'll go ahead and make sure we're above the gasket. Pull that up a little bit. Get your finger in there.
Okay. There we go.
And we still have the gasket down there. Here's that locating pin I was talking about. Makes life a little bit difficult. Now put one hand under here and one hand under the other side. So we've got that broken loose. Now I'm going to take my hands on this side and finish breaking my side down.
I feel like I'm living my best sci-fi movie life. Like,
wait till Hal starts chiming in.
This is like Cocoon.
Okay, gonna wiggle it a little bit to get it up above the tape. Now, can you look down and make sure that the gasket has stayed with the case?
Yes, it has.
It's not in our hands.
Confirm.
We're gonna take about 3 steps backwards, gonna tip it down and rotate it 180 degrees and lay it right on the floor.
Whoa.
So you can see the reveal. We're going to take our PPE off temporarily, make ourselves safe, and then we'll come back and do a little bit more narration, and we'll have Tracy do some high voltage testing on these packs.
So, Bill, this battery is still live, right?
Yeah, that's the thing about a high voltage battery. While I'm able to tell the car to stop all the energy from going out of the battery without physically using a device to drain the energy out of the cells, every high voltage battery you work on will be live once you get it out of the car. In this case, there was a manual service disconnect that sat underneath where we've taped off here that joined in a series, this pack, this pack, this pack, that pack, this pack, the whole way around. When I pulled that out, I split this battery in half. Literally broke the circuitry between this point of the battery and that point of the battery, rendering it to 188 volts on that side and 188 volts on this side. Some of the highlights that we see here underneath this big orange cover is my contactor pack. That's where my service main relays or my service contactors are going to be. My pre-charge relay, my 2 high voltage charging relays are going to be here. And this one also carries a relay to join 2 110 volt circuits together to make a 240 volt charging circuit to push everything into this battery in order to recharge it. When we look at these batteries, they're constructed of many, many small cells put together. In fact, I'll go ahead. We'll take a minute. I'll show you how these batteries constructed on a very, very small level. Right now, I think what we're going to do is we're going to get some safety glasses on Tracy. We're going to go ahead and hook up a Cat 3 meter. And we're going to start taking some voltage readings from the back of the pack towards the front to show you guys how we build up module voltages in a series to get to that 360, 380 volts that these cars are actually running right now. So let's get a meter out. I'll make sure that the meter gets proven out to make sure that it's good. We'll go over all that with Tracy to make sure that she has that muscle memory, and then we're going to do some live high voltage testing inside of here. At the same time, I'm going to go ahead and show her test points as we go through, and we'll call out the readings that we find as we start building that voltage higher and higher towards the back of the pack. So let us get the meter on, get ready, and we'll show you what we're going to do next.
Are you a NAPA Auto Care Center who is ready to take your shop to the next level? Then the premier tier NAPA Auto Care Gold Certified program is exactly what you need. Gold Certified Auto Care Centers provide customers with a consistent experience no matter where they are in the U.S. Now, this means they are more likely to return and support your shop or find your Gold Certified Auto Care Center while on the road. Gold Certified members can maximize technology, increase their local marketing opportunities, and have a fully trained team that keeps up with the latest trends. Simply put, the Gold Certified NAPA Auto Care program, powered by your local brand, will set you apart. A true partnership is a two-way street. Shops must meet specific criteria to be eligible for the many benefits of Gold. Now, NAPA Auto Care rewards its most committed partners, their Gold Certified members, with free premium shop referrals on the NAPA online locator, annual marketing dollars, and enhanced warranty, training opportunities, program rebates, and so much more. Are you ready to get started? Contact your local NAPA sales representative to discuss your eligibility and apply today. More than 16% of light-duty vehicles on the road are EV and hybrid. Is your shop ready to safely and properly service them? Get your shop trained and equipped to service hybrid and EV vehicles with NAPA Autotech's innovative EV-ready Level 1 high-voltage awareness and maintenance training. Hey, take your auto care center to the next level, the gold level, with the NAPA Auto Care Gold Certified program. This program is for the best of the best who can provide a consistent consumer experience and earn the trust of returning and new customers. Talk to your NAPA sales representative about how you can become a gold certified shop.
So now we've proven the meter out with the 240 volts. In order to maintain a one-hand testing technique, I'm going to use the alligator clip, and we're going to connect down here to the output of one of the battery cells, the last output before it goes into our contactor assembly here. So I'm simply going to take the negative side of my meter. We'll put it down here where it's not going to hop off. We've got a nice secure connection. And now we're going to go back and test and watch the amount of voltage in each one of our packs. And we'll see where the voltage starts to build up from a 39 volt, or nominally call it a 40 volt pack, to an 80 volt in the second pack, to 120 in the third pack, and so on and so forth. By the time we get back to our last contact point where we're going to test, we'll be up over 188 volts. So I'm going to go ahead and get us an insulated sheet so we can put our meter up on top of the battery, and we don't want it to go ahead and contact anything inside of the battery. And then we'll go ahead and do our test. So let's get the insulated sheet out. I'll put it down on the battery, and then we'll start doing our testing. If you've ever seen surgery, they cover up the whole patient except for the part that they're working on. And that's essentially what we want to do here, because I don't want tools, debris, dirt, my sweat, whatever's going on here. I want the least amount of chances of anything entering this battery pack as possible. So right now, we're just going to use it to make sure our meter doesn't cause any problems for us. We will untangle our leads so we don't go ahead and pull them off.
Now, how much does this whole thing weigh?
This battery pack is between 1,000 and 1,200 pounds. That's one of the smallest ones that's out there. It does require a dedicated lift table, not just a powertrain lift table, but if you get to the new Hummer from GMC, that is a 3,000 pound battery pack. So they're very, very heavy. It's nothing that you're going to do with a transmission jack or modifying a milk crate. I've seen some horrific ideas on the internet that I would advise against. If you're going to do this kind of work, you're probably going to have to invest in the proper equipment, the proper tooling, and the proper PPE, and some training to get inside of here. I am nervous inside of this every time because of the amount of energy that's stored inside of here, and it's a good nervous. We don't want to make silly mistakes. We don't want to create a situation where we harm ourselves. So everything we do inside of here is done with purpose. All the tools that we will use inside of here, insulated tools. The insulated tools are not just to insulate me from electricity. They're also to insulate themselves for an accident. If I dropped it in, there's very little exposed metal content. Our tools cover the metal up with a lot of insulation to make sure that there is no exposed metal content that could go ahead and fall, to the point where even some of our sockets have small retention balls on them to go ahead and hold that screw in, so you can use it as a screw starter, because of the amount of danger that could happen if we got sloppy or maybe didn't spend enough time doing the proper thinking ahead of time. A lot of this is being very cerebral and understanding, 2 or 3 different times, what am I about to test and what is my expectation of what I'm going to see.
How many shops would this be occurring in that they would need to take the cover off?
So this particular pack does have sort of a notorious background to it. They had some issues with the original generations of this pack. And in fact, if you look on the back of the cover, there's a little N2.2 sticker in blue on this cover. That means it is the second generation pack that General Motors has put out for this vehicle. The original generation of these packs suffered from we'll just call it thermal runaway issues to be polite. There were some charging issues and some fires attributed to cells in these things, so they got a very bad reputation. Why a technician would be in here, you are able to replace a stack of batteries called a module. You are able to replace the contactors inside of it. And more importantly, if we come up and take a look at the front of the battery, with the battery orientation, the way that it sits inside of the car, this is the front edge, the leading edge of the battery pack. I see 2 coolant lines and 2 high voltage lines that are going to be suspect to road debris and damage from curbs, from driving over things, the typical things that we see in a shop. So on this particular battery pack, I would imagine that people are going to get in for one of 2 reasons, either because we have a coolant problem because of corrosion or a leak on the outside of the battery requiring some of these components to be replaced. General Motors will tell you if you get inside of this battery pack and there's any coolant inside of it, the whole battery pack needs to be replaced. Battery packs and coolant do not mix. That's why I was kind of careful in the beginning to explain to you that even though the coolant enters the battery pack, it is captured in a small cooling manifold and never actually touches the battery. The coolant acts as the heat sink to pull the heat out of the battery, but we never flood the batteries in any kind of coolant because we learned in preschool that, electricity and water do not mix. In fact, we are in October. We just went through some horrible weather all over the country. And what has happened is these battery packs, they have to be able to breathe. When this battery pack gets hot, it has to be able to expel some air. On the top of that cover, there's actually some small Gore-Tex patches that allow air to expand and water vapor not to go in and out of the battery. The problem is if you immerse this battery when it's warm and you park it, and now we have condensation, just the natural vacuum that gets formed inside of it as it cools tends to pull some moisture in. If we add salt water in a flood vehicle and it's above that Gore-Tex patch as it's pulling it in, or if it sits underwater for a while, we end up with water intrusion into these. Fresh water, salt water, of course, would be way worse than fresh water because of connectivity, but it really doesn't matter at that point. When you get water inside of a battery pack, you have water and electricity mixed, and that's not a good combo for anybody. So what we're going to do is, you can see I have some numbers over here because we've done this with some classes before. We're going to take our red lead, we're going to look at our voltage. All right, now we can take our meter, touch that connection first, and you can see that we went into these cells, back and forth, positive, negative, basically putting all these batteries in a row in a series, and we've added up to 40 volts at that point. So that is the voltage between here and here. Those batteries are providing us about 39.2, we'll call it 40 volts. If I come to my second test position, which is going to add the second pack, and we touch there, you'll see that we're up to about 78.4, or about doubled what we did there. If I come to my third test connection, which is going to be this one over here, we're up to 117 volts. So basically 40, 40, 40 the whole way through. Our fourth test connection, which is going to be taking this pack in right here, insulated screwdriver, by the way. So it's just a small tab there that we have to release to pull up, and we can get to number 4 there. Now you see we got up to 156 volts on that one, and then our final test is going to be right here before we go into that manual service disconnect, and that should get us to 188 volts.
Yep.
Now, if we want to measure the voltage between each one of these individual modules, we're going to do it in the back, but I'm going to end up moving this lead for you, and we're going to come over and we're going to measure the voltage between this pack, which is the one going in here, and this pack, which is the one coming out. So see if we have around 40 volts between our 2 points here. 39.2, the same as we had before, right? So let me move the lead one more time. We'll move it up to here, and we're going to measure over to that point now. Now that voltage is not 40 volts, is it?
31. 31.3.
So that module has a different voltage on it because it's physically smaller than the other modules. In order to fit the wiring and the computers, the two modules in these backs here are actually a full-size module and a shorty module. And over on this side, it's full-size on the bottom, shorty on this side. So that's why there's a anomaly. They didn't build 40 volts or 39.4 volts every time, because one of these, the top one in this case, the bottom one in this case, is actually minus a cell or two. And that's why they're going to have less voltage. But you can see we basically, and if you take a picture of a D-cell mag light way back in the day, if I put 2, 3, 4, 5, 6, 7, 8 D-cells in a row, we build up the voltage because they're in a series. And that's how we get from 188 down this side, 188 down this side. If I put my connector back in here and connect both the module sides together, we would have that full 400 volt or 378 volt battery pack at this point.
All right, Bill, what is this part here?
Well, that's actually what we call the Beckham. And no, it doesn't play soccer.
Okay.
It is a battery energy control module. You'll notice that we have two different colored cables here. All of these orange cables are going to the individual cells to tell me what the voltage are, and there's also some temperature information that we get. The control and the 12-volt side that communicates with the rest of the computer are on the two black ones here. If you'll notice, they're numbered on the top. That's because there's a specific order according to the manufacturer that we have to remove these plugs in. If I unplug a high voltage cable first, it will see that battery as low and it will try to balance it, even though there's no battery there, and it will burn this module up. So there's even a specific order when it comes to service information. This is the first one, the second one, and then it's counterclockwise until you get to eighth.
And you put these numbers on.
I put the numbers on because when we go through it, I want to make sure that not only do I share my experience, but I have these numbers and these little reminders of like, oh yeah, I've got to tell you guys this. Service information told us that it has to be in a specific order. And all of these little tricks that we have inside of the battery, and there's some more that we'll talk about. For instance, if we go to the front of the battery, you'll see that I have put some auxiliary tape, some electrical tape there. And the reason we do this is if I'm going to go ahead and pull these modules apart, I want to make sure that this bus bar goes right back where it's supposed to.
So after seeing all the numbers that you have placed, not only here, but around, it really seems like you have to RTFM the entire process.
Oh, that's very, very fanslow. So read the freaking manual. I got to tell you, if there's one thing that more technicians need to be cognizant of and need to start doing, today's automobiles, they don't work the same way as they did in the 70s and the 80s. They're not engineered the same way. You can't expect to fix them the same way. Knowledge and information are the first two things that you have to have before you even form a plan to fix a modern automobile. And small mistakes, just some of the things that we talked about, the little metal washer flying off inside, unplugging it the wrong way. Well, now we're into a $1,200 to $1,300 module. And when would you know that was bad? Not until you assembled the whole pack, put it into the car, and then fought for days to figure out why it didn't communicate, because it worked when I gave it to you. And it was all because we didn't RTFM and do what was the proper and prescribed technique for every one of these operations. They will tell you exactly. For instance, these modules, if I ever replace these modules, there's actually a holding fixture. You cannot just pick up this battery module. It will sag in the middle and it will damage the cells. When you pull them up, these big metal bars, you'll attach a cherry picker or an engine hoist to it, and it will lift the cell up as an independent unit. Wow. And it will keep it flat the whole time. So a lot of, we'll call it barbaric ways that we used to repair automobiles, flop this to the side, flat rate it, bungee cord this to the fender. Guys, I got to tell you, we really have to embrace taking a car a little bit further apart to make your job easier, as opposed to bending something out of the way when we start talking about these high-tech cars. I don't believe there's a component in this battery that you can have for less than $250 to $300. And that's just a connector or a contactor. If you have to buy a Beckham or a module or a bus bar or a wiring harness, those costs are just astronomical at this point.
You have to be really intentional on every movement you do.
And you're around electricity. So to me, that came as second nature, because electricity is one of those things that I think everybody should have a healthy caution around it. I don't want anybody to be afraid of it, but I do want you to think every time before you make a move, before you go ahead and touch something, before you decide to take off your gloves, I want everybody to think 1 or 2 steps ahead. It's the difference between playing chess and checkers.
I love that.
All right, so I've got some dissimilar pieces, but I think it'll take us inside of a battery to how we actually put it together. So again, we have the insulated mat, so I feel pretty safe about putting this down. This is an individual, what we call a pouch cell now. So it has a positive side and a negative side. It has an anode and a cathode, and in between it, we have a separator, and this is the lithium battery that you think of. So think of your cell phone, think of your Milwaukee tools. This is a lithium pouch cell. If we took 2 pouch cells and put them together, positive to positive and negative to negative, this would be in a parallel. So we didn't multiply voltage, we multiplied capacity. So if this had, say, 100 amp hours or 100 milliamp hours, it now has 200 milliamp hours. The other thing that happens when we put 2 batteries together like this is we lower the internal battery resistance because we have 2 paths for current to go through. So we take those 2 cells together in a parallel and we put them in a plastic cage to make 1 small battery. Then we take that battery and put it down inside of here, and we would put 96 of these in a row, 96 cells in this particular battery pack to get us up to that 400 volts. So it all starts with basically a mylar balloon, if you will, that is an individual lithium-ion battery, 2 or 3 together. Early volts had 3 in a parallel. The later volts had 2 in a parallel. This bolt has 2 in a parallel. My Ford Mach-E has 2 in a parallel, but the extended range, I think, has 3. So depending on how they wire the batteries together, you'll see in the battery pack information, it'll be 1P for 1 in a parallel, 2P for 2 in a parallel, 3P for 3 in a parallel, and then there'll be an S number for how many cells in a series.
I am beginning to understand Isaac's t-shirt a lot better. Parallel killers and serial killers.
Absolutely.
So I feel better because he gave me one, so I'm going to be wearing one. Now I have a better understanding.
So here's another t-shirt for you. I've lost an electron. Are you positive? Those are all just nerd jokes, you know how we go around here. The study of electricity, and a lot of technicians struggle with this, so if I could give anybody some advice out there, please understand 12-volt systems backwards and forwards. Understand a voltage drop. Understand the relationship of resistance and amperage and voltage before you ever decide to go into the realm of this high voltage. It is so important to have an understanding and respect before you touch it. After that, when you get somebody to guide you, a lot of people would be afraid for what we're doing right here. As long as we maintain ourselves and we think before we do anything, there is no point on this battery that I would make my students or yourself feel unsure that you are not safe. Now, with that being said, there are plenty of opportunities for us to do dumb things inside of a battery that we want never to happen. One thing that we did today, one thing that we always do in the classes, I will let you walk right to the edge of that cliff. That's why we want everybody to move slowly and methodically in these classes, because I'll let you get there and I'll ask you, what are you about to do? Are you going to make yourself unsafe with this action that you're going to do? And that's one of the biggest things, not only to read the manual, but to plan ahead, be that chess player, understand that you have the tools, you have the technique, you have the stuff within your reach, and then just use the mechanical ability that you obviously have, and you're well on your way, to go ahead and apply the knowledge that you have to fix a car successfully. Now, are we going to get to the point where we replace module in these things on a regular basis? Only the future can tell me that. What is the supply line going to look like? Are they going to be able to be purchased in the aftermarket for us? I don't know. What I do know is the components that we might have to replace in here, my contactors, my hoses, my battery energy control unit. We just want to make sure that everybody knows how to safely remove the battery pack, safely disassemble the top of the battery pack to get access to the particular components that they may want to replace on the inside. So we've done some testing inside. One of the most important things we've done is go back to make sure that we removed all of our tools, to make sure that everything that we used inside of the battery pack is removed from the battery pack. We made sure that all our test points were closed. Now we're going to gently pick up our battery pack cover, stand it straight up, and we're going to put it right back where it came from. We'll put the bolts back in it, we'll torque it back down, and I'll put it back in the car. Now your side has that little pin on it. See where it goes? on that back side, that little pin that sticks up.
Yep.
And I have a pin on my side also.
Bye-bye, battery.
Now the battery pack's covered up. We'll go ahead and take off our PPE, leave our gloves on, and we'll put all the bolts and torque them into the vehicle.
Thank you so much, Bill. This was a wonderful experience. You showed me how to put all the bolts back, and it was a very specific order, RTFM. And I like how you have all the numbers labeled. You did that yourself.
Correct.
Right?
And if I was a technician in a shop, honestly, for the amount of time it took me to do that with a marker, as opposed to going back to your piece of paper or back to your service information, this just makes my job easier. Even though I know I'm going to do this multiple times, honestly, if I was going to do it one time, and if I had an apprentice that wanted to learn, or if I wanted to do it myself to make my life easier, you saw how we skipped around from corner to corner, then to back, then back up front, then around this side. It's a very specific order, but it isn't intuitive. Let's just say it that way.
It was wonderful to see this, the size of the battery. I mean, I didn't even know what to expect. To see this size and what was underneath it was really impressive.
Well, the whole idea is to give people a visual reference. I mean, we know you, we know your channel, we see stuff out there, and I can imagine that most of the technicians out there have not been inside or have the privilege to see the inside of the battery. Now, are we all going to get in there and do this kind of work? Obviously not. It's just not that broad spectrum of work that's going to be out there. But those of us that choose to go forward in our electric or EV car career, this is just great material to see how they're constructed, how to go about working on them. I mentioned the Gore-Tex patches a little bit earlier. These are what I'm talking about, so you can feel them. There's actually a hole in that battery that would go the whole way through. So that little patch, there's one there, there's one here, and there's another one over here on the penthouse. So if this vehicle got immersed in water, not splashing water around, not typical driving, but it is possible for those, even though it's supposed to keep the water out, it is possible for water to get inside of these. So flood vehicles are a big concern, especially right now with everything that's gone on. You asked a little bit earlier about the marks, and you'll notice that we also have those marks from somebody who put the glue on and put the correct foam pad on to stop the vibrations up against the floor. So all that does is stop vibrations in this plastic cover from being able to rattle underneath of you. But the witness marks, or the chalk marks as we call them, even though it's a paint stick, that was just somebody at the factory that, yes, I've completed this task.
Now, if this vehicle was in a severe car accident, what would this look like?
So it depends on where the accident happened. One of the biggest concerns that we would always have with an EV accident is some kind of intrusion into the battery. In fact, most insurance companies, if there's anything around the battery, any damage to the battery, they'll take that car and they'll total it at that time. My concern as a technician, if I had a vehicle come in, and it doesn't have to be a heavy accident. If we have customers that run over something on the freeway, remember, that is the bottom of the car. And we've all replaced an oil pan or a transmission pan because somebody ran into a curb or ran something over on the freeway. My first concern would be to get out into the parking lot, not even pull this vehicle into my shop, and do as best of a visual inspection as I can on all the high voltage components to make sure that I don't have a problem, a perforation, or something that's obvious where I would know that I did not want to pull that vehicle into my shop. The best advice I can give anybody about a damaged or a wrecked EV is when you pull it to your shop, when it goes to your shop, let's find a corner of the parking lot to put it in, far away from anything that could go ahead and become a source of fire, and let that vehicle sit out there till a certified technician, somebody who's been through electrical training, gets a chance to look at it, hooks a scan tool up, sees if there's any memory of the car having a crash or why, or if it's in some sort of a crash lockout. Most of these cars, upon a crash or upon airbag deployment, it'll take the battery and open up the contactors, and it'll put it in a battery lockout state that you physically have to go in with a scan tool and tell it it's okay to wake back up again, because they don't want a first responder to key the vehicle up and then, somebody in the car gets electrocuted. So that is a safety system that's built into most of them.
Now, I hear you'll be at Vegas for AAPEX this year?
Yeah, this is one of the reasons we had you come down. So at AAPEX this year, we're going to be over at Joe's Garage, and we're going to feature what a modern EV bay is going to look like. So I'm going to take our Chevy Bolt, and each day we're going to remove this battery. We're probably going to leave the cover on just because of the amount of extra danger that we would add at this point. But we really want to highlight the tools, the techniques. So we're going to have 2 people removing the battery, and we'll have one up front that'll actually answer any of your questions that you have about the bolt, about the process, about an EV bay, some of the things that we'll be taking. We'll take off our cones and our pieces of equipment we need to delineate a work area. We'll take our high voltage signs. We'll take all our personal protection equipment. Although not going into the battery pack, it'll be limited to what we actually have to wear doing that job. We'll take the scan tool and show everybody how to properly shut the vehicle down. And then after we put the battery pack back in, we have to fill this battery pack and cooling system back up with a 50-50 mix of the correct antifreeze and the correct water. So we usually just buy pre-mixed, and then you'll fill it using an airlift system. And then service information tells us you have to maintain a vacuum on that system while you run the pump for at least 5 and maybe up to 20 minutes, depending on make, model, and year. So again, RTFM, you're not done when you think you're done, and you can't just trust your customer to road test this car. It's up to us to put it back together the correct way, properly fill, check for leaks, follow all of the service information, do our road test, make sure we have no codes in it, and then and only then do we know that we're giving back a fully functioning EV back to our customer.
All right, last thing. With your permission, I would like to use you as a reference because Matt Fonzo still will not hire me as an apprentice at his shop.
Matt, you should be ashamed of yourself. Matt, seriously, the girl has put together an unbelievable resume on video. She's done tires. She's done high voltage testing. She's done batteries. I don't understand.
We're opening up a whole can of worms here.
I'm going to get that call, and it's going to be so fun.
Thank you so much, Bill. I've learned a lot, as usual. Thank you for having us down here, and I can't wait for the next time you call me and say, I have another idea for filming, because we will be here.
We've got some other stuff in the works. I think we're going to work on charging and actually looking at the modules and, for a lack of a better term, discharging and charging them up to equalize them. I think we'll work on that type of technology next. And when I get that developed, we'll have you guys out once again, and we'll do some filming on correcting the batteries.
Thank you so much, Bill. Thanks, everyone.
Thanks for being on board to listen and learn from the premier automotive aftermarket podcast. Until next time,